In this lesson, we are going to go over graphs of piecewise functions. Specifically, we'll be reading input and output values given the graph of a piecewise function. We'll determine the domain and range of piecewise functions from a graph. And given a graph of a piecewise function, we'll determine the rule. So we'll be filling in the inputs and outputs, formulas, and the domain given the graph. Okay, so let's get started. So refer to the graph to find the following. For what value of x is f of x equal to 5? So remember, this is our input and this is our output, or our y value. Okay, so when y is equal to 5, it's looking for x. So here on the function is where the output is 5. We go down to the corresponding x, that's at 1, 2, 3. So this would be x equals 3. Okay, for what is f of negative 2? So negative 2 is our x value, or our input. Okay, and if we go to negative 2, on the x-axis, we go to the function, and the corresponding y value in this case is also negative 2. It's negative 2 because that's the y value of the function when x is negative 2, not because that was the input value. Next, we're going to go over domain and range. So recall that domain is the x values of a function and range is the y values of the function. Okay, so find the domain and range. So first, for domain, it's all of the x values. So as we read this function, even though we have multiple pieces, starting from left, we start out way x big negative numbers. There is an x value at 2, and then we keep going. Okay, so it goes all the way from negative infinity up to 2. 2 is included because there's a point here, and that is part of the function, and then it includes values greater than 2. Okay, so our domain here is negative infinity to infinity. So for every x value, there is an output, is what we're looking at. Okay, the range, in this case, we've been talking about reading it bottom to top, but we only have 3 values of the range. Negative 5, 2, and 4. Okay, so when you've got distinct values like this, when you don't need to use interval notation to include infinitely many values, we use set notation and we list the values. So 5 from the blue line, 2 from the purple dot, negative 5. I think the negative being covered up is messing me up. And then from the green piece, 4. The y value is 4. Okay, so that would be the range. Next example, give a rule for the piecewise defined function. So this is where you're going to look at the graph, give the output rule for the correct domain. Okay, so let's start. We usually start with the smaller x values, which occur in terms of the green line that we see. Okay, so you may decide to determine the y formula, the output formula first, or the domain first. I'm going to look at the domain. So this is x is 2, and since there's an open circle here, it's going to be less than 2 for green. Okay, notice we have a horizontal line. The equation of a horizontal line, it's y equals, it's a constant value, and in this case, it would be negative 1, 2, 3. Negative 3. Okay, so this is y equals, or our output equals, or the function equals, negative 3 when x is less than 2. Let's go to the red piece. So it starts at values x equals 2, and there's a closed circle there. So it's going to be a greater than or equal to 2, because it starts at 2, 2 is included, and then the values get bigger. Okay, we have another horizontal line, and that's at 1, 2, y equals 2. So for that output formula, it's just 2. So no matter what the x value is, y equals 2. X is 9, y is 2. X is 100, y is 2. So that's our formula. Now let's look at the domain and range. So the domain, again, we start from left to right. You can even get it from the formula that if you look at this formula that we just wrote, every single x value is included from negative infinity to infinity. Okay, everything less than 2, everything greater than or equal to 2, negative infinity to negative infinity. Okay, but if you look at the graph again, left to right, we go from the left, there's an open circle here, but it's closed here, so 2 is in the domain, and it keeps going. So our domain is negative infinity to infinity. For the range, again, we only have 2 values, negative 3 and 2. So we list them out in set notation. Okay, the reason it's not negative 3 to 2 or negative 3 to 2 these both mean everything in between. So this means negative 2 -1, 0, 1, 2, and everything in between, infinitely many values in between. But that's not the case. We only have 2 values in our range. Same thing here. This would include -3 and -2, but again, it would also include -2.9, -2.8, -2.7, which is not what we have from this function. Okay, there's only 2 values, 2 y values, -3 and 2. Okay. Next, let's look at an application. So sketch a graph that depicts the amount of water in a 25-gallon dog pool. The pool is initially filled at a rate of 5 gallons per minute, rate of change, slope. Immediately after it is full, my dog jumps in, pokes a hole, and water escapes at a rate of 2 gallons per minute until it is empty. So what's happening here is the pool is filling at 5 gallons per minute. So 1 minute goes by, we're at 5 gallons. Another minute goes by, we're at 10 gallons. Another minute goes by, we're at 15 gallons. Okay. The maximum amount of water is 25 gallons. So it gets to 25 gallons, dog jumps in, pokes a hole, and then water escapes. Okay, so again, we're talking about a rate of change, but since we're losing water, our slope in that case would be -2. So a minute goes by, we lost 2 gallons. Another minute goes by, we lose 2 gallons, and so on and so forth. So when you're asked to match a graph, you're asked to model what's going on here. And so I have the graph here, and we'll talk about it. So as the pool is filling, the slope here is +5. Okay, all the way up until we get to 25 gallons. Okay, so this would be 25. My dog pokes a hole, and water is released at a rate of 2 gallons per minute. So this would be -2, would be our slope here, until it's empty. So once it's empty, it has to reach 0, because the y-axis represents how many gallons are in the pool. X would be minutes in this case, but this is what we would be looking at. Thank you for watching. If you have any questions, feel free to reach out to me.